Let's talk about a piece of technology that is so fundamental to our lives, it's basically invisible. Yet it powers almost everything we do with a screen. We are, of course, talking about the C programming language. And, unless you're a systems programmer or maybe you took a particular computer science class, chances are you've never touched it. It's not flashy, it's not the cool new thing on the block.
But, and this is the hook, from the second your computer boots up to the moment you tap send on a message, you are depending on C. It is the absolute bedrock of our digital world. So just how deep does this rabbit hole actually go? Let's take a look at the world that is, quite literally, built on C.
It is, and I'm not exaggerating, everywhere. The kernel, the absolute core of the operating system you're using right this second, written in C. The drivers that let your computer talk to your mouse, your keyboard, your screen, all C. And it scales like crazy, from the world's biggest, baddest supercomputers, all the way down to the tiny little microcontrollers inside your smart thermostat or your car's engine. It's the language that speaks directly to the hardware.
What's just so fascinating is that this language that spans the entire globe wasn't some grand plan. Its creation, well, it was almost an accident. It was a side effect of trying to solve a totally different problem.
For this story, we've got to go back to the legendary Bell Labs and to two absolute pioneers, Dennis Ritchie and Ken Thompson. They weren't setting out to create the next big programming language. They were just a couple of guys trying to build a better operating system for themselves.
And just look how fast this all happened. In '69, Ken Thompson makes a language called B. It was a good start, but it was pretty limited. By '71, Dennis Ritchie is already improving it, adding crucial things like data types, which let the language know the difference between, say, a number and a letter. He called it New B. A year later, it's just C. And then boom. 1973, they rewrite the entire Unix kernel in C. This was absolutely revolutionary. An entire operating system written in a high-level language meant you can move it to different computers without rewriting everything from scratch. The idea of portable software was basically born right here.
And this brings us to a famous and pretty witty quote from Dennis Ritchie himself. It just perfectly sums up the whole philosophy of C. It gives you this incredible raw power, but it also expects you to know exactly what you're doing. There are zero safety nets.
So let's really dig into that philosophy. What does it actually mean for a programming language to be close to the machine?
C is what's known as a systems programming language. It's not really designed for building your average website or mobile app. No, it's made for building the very systems that other software runs on top of. And to do that, you need direct, fine-grained control over the computer's guts, especially its memory and hardware.
Okay, this is where it gets really interesting. If you've ever used a language like Python, it feels kind of magical, right? You create things and the language just handles all the memory details for you. C is the complete opposite. You, the programmer, have to manually ask for memory and, this is the important part, you have to remember to give it back when you're done. You use these things called pointers to talk directly to memory addresses. It is way more work and frankly, way more dangerous. But the payoff? Ultimate control and blistering performance.
So this amazing combination of raw power and portability is what turned C from a cool internal project at Bell Labs into a global phenomenon that basically fueled the entire personal computer revolution.
A huge reason for its success was standardization. In 1978, Kernighan and Ritchie published the book on C. It became the unofficial Bible, what everyone called K&R C. But for a language to truly work everywhere, you need official rules. That led to the first formal standard, ANSI C, in 1989. And ever since then, the language has been carefully managed and updated all the way to the latest standard, C23, in 2024. That stability is a massive reason why it's still so relevant today.
And if you need proof of its staying power, look no further. C has consistently ranked in the top 4, that's right, top 4 most popular languages on the TOB index every single year since that index began back in the early 2000s. After more than 50 years, it is still an absolute titan.
But this brings us to the core tension, the central paradox of C. Its greatest strengths, the very things that made it so successful, are also the source of its most famous dangers. So, why do people still choose C in the modern era? Well, number one, performance. It runs close to the metal, meaning it's incredibly fast with very little fluff. Number two, portability. Write standard C code and it'll run almost anywhere. You also get that total control over memory, letting you squeeze out every last drop of performance. And on top of all that, there's a massive battle-tested ecosystem of tools and libraries for just about anything. Okay, but here's the other side of that coin. That manual memory management, if you forget to free memory, you get a memory leak. If you accidentally write data past the end of where it's supposed to go, you get a buffer overrun. And that's not just some nerdy term, it is the root cause of some of the most catastrophic security holes in history. Think of the Heartbleed bug that exposed millions of people's private data. That was a buffer overrun. These aren't just bugs that crash your app, they can be doors that let attackers walk right in. C trusts the programmer completely, which means it won't save you from yourself. And yet, despite those dangers, C's influence is just impossible to overstate. It didn't just become a language, it became the lingua franca, the common tongue of the entire programming world. I mean, just look at this family tree. The syntax of C, the curly braces, the semicolons, the way it's structured, it became the blueprint for almost all of the world's most popular languages today. C++, Java, C#, even JavaScript. When you learn C syntax, you're basically learning the Latin from which so many other languages evolved.
And here's the real kicker. It goes even deeper. You know all those convenient high-level languages like Python and Ruby? Well, the official programs that actually run your Python or Ruby code, they themselves are written in C. So when you're writing Python, you are, in a way, running a C program under the hood. C isn't just a foundation, it's the foundation that other foundations are built on.
Which leaves us with a really fascinating question to chew on. C was designed for an era when computers had less memory than a single photo on your phone today. In our world, where security is absolutely paramount, is a language that puts raw performance above all else, including safety, still the right bedrock for our digital future? There's no easy answer, but one thing is for sure. The legacy of that accidental revolution from Bell Labs is still with us every single day.